Billions of cilia line the human respiratory tract. The motion of each cilium is nearly identical and ordered sequentially to create an undulating pattern called a metachronal wave. As extensions of the epithelial cell's surface, cilia are individually powered and move in a coordinated manner to propel mucus and foreign debris across the tissue surface, away from the lungs, through the respiratory tract, to locations where they can be expelled from the body. The stroke cycle of each cilium is nearly identical and consists of a power stroke and a recovery stroke. The power stroke is in the direction of flow. During the power stroke, the cilium is stiff and perpendicular to the tissue surface, creating the greatest force. During the recovery stroke, the cilium relaxes, bends, and swings to the side. This yields the least resistance as the cilium slides into position, ready for the next power stroke. Each cilium is on average 5 micrometers tall and contains an internal skeleton of microtubules arranged in a 9+2 configuration. 9 microtubule doublets composed of an A tubule and a B tubule surround 2 individual central microtubules encased in the central sheath. Several linking structures connect the outer microtubule doublets to the central core of the cilium and to each other. Radial spokes connect each microtubule doublet to the central sheath. Nexon links connect each microtubule doublet to the adjacent doublets. Inner dining arms and outer dining arms also attach adjacent doublets and power the motion of the cilium. Inner dining arms and outer dining arms affix themselves to the A microtubule of one doublet and walk down the length of the B microtubule of the next doublet, pushing the adjacent microtubule doublet tipward and creating a sliding motion. Because the 2 doublets are connected by Nexon links and radial spokes, this sliding motion is translated into a bend. The dining walking action occurs along different sections of each microtubule doublet throughout the stroke cycle. The dining arm activity starts at the base of each microtubule doublet and spreads towards the tip, creating a spiraling pattern. The particular pattern of dining activity along each of the 9 microtubule doublets causes the different characteristics of ciliary motion throughout the stroke cycle. During the power stroke, the cilium is stiff and bends from the base. During the recovery stroke, it bends all along its length to slide underneath the surrounding medium, avoiding resistance. The proper functioning of the lungs, nose, middle ear, and sinuses is dependent on cilia, and ciliary dysfunction may cause a wide range of respiratory problems. Chronic lower respiratory tract infections, chronic rhinitis, sinusitis, and middle ear infections may all be caused by the inability to clear mucus and debris from the respiratory tract.